All right, this is basic energy concepts. And as you can see, this is topic 2 of our thermodynamics module. And there are no questions on the NRC exam, but this does lay some very important foundational information out there. And so it's important that both chapters 1 and 2 for thermodynamics kind of seem kind of maybe real low levels, such that why am I even reading this? Super important, at a minimum, just to kind of knock the dust off if you've already had this stuff before. But they are foundational, such that when we get to chapter 3, topic 3, and beyond, that it's understood that you kind of understand units and properties and unit analysis, as well as what's contained in here in topic number 2. So in topic number 2, you will see that it starts out with an introduction, and we've already talked about it a little bit, but first of all, it says that we can have certain forms of energy. And the forms of energy that we're going to be concerned with are potential energy, kinetic energy, pressure volume energy, the energy that I can have to having because I have a pressurized fluid, and internal energy. So we know that this is due to height, z. I know that this is due to velocity. This is due to having pressure and volume, such that I could expand across a windmill or a turbine. And this is internal energy that is kind of temperature related, but it's more than that. So those are the forms of energy that our working fluid is going to have. So if I take a pipe, and I've got my working fluid flowing in the pipe, and I want to take an energy measurement of it, well, it could have some potential energy because how high is the pipe elevated? There's a certain velocity in there. It's got a certain height, possibly. Does it have a certain pressure and volume? And what's its temperature or internal energy? Those are all the energies that could exist inside my working fluid. So these are going to be the 4 big ones. And I will tell you, we're actually going to combine these 2 right here. That's going to be very important. We're going to call these H, where H is enthalpy. Enthalpy. That'll be introduced in this topic. So some things we have to discuss. Our working fluid. Anytime that the state changes, that is going to define a thermodynamic process. So what we're saying is, what is the state of fluid? The state of my working fluid? State of my working fluid can be determined when I know its properties. So if I know its temperature and its pressure, and I know its volume, and I know its internal energy, I can pinpoint its exact state. And if any one of these properties change, there has been a change in state. That's a state change. Any one of the properties of our working fluid changes, there's a change in state. So when I go from the inlet to a pump to the outlet of a pump, I had low pressure water here. Now I have high pressure water. There's been a state change. It was still water though. Nothing happened to the phase of the water. And that's the next thing we talk about. So the state changes anytime you change one of the properties, and I can pinpoint the state of my working fluid if I know the properties that exist. The next thing is the phase of the water. Phase. Well, as you're looking on the upper right-hand section, section 2.2, you're going to see 5 phases there. But in reality, our working fluid in our cycle is either water or steam. So we really only talk about 2 phases. But we will discuss what happens when I have the solid phase called ice. This is a solid phase. Solid is one of our phases. And I know that if I add heat to ice, it melts. And the entire time it was melting, its energy was being raised. And now here's a puddle of water. There's been an infinite number of state changes here, but now I've gone from a solid to a liquid. Well, that is a phase change. And here's my symbol for phase. There has been a phase change. Phase is nothing more than the molecular spacing. So, and we have 3 different phases of water we talk about. Here's the molecular spacing in ice, where it's really, really tight. And then as I add energy to it and turn it to water, well, it's a little bit less than it was. It's not so, hard. And obviously, it's got different spacing. And if I added energy to this liquid, I can actually turn it to steam. And we can see what's happened. I mean, this is steam. Here's liquid, and here's a solid. These are the 3 phases of water. There's 2 additional phases listed as gas and plasma, but we don't talk about those phases. We understand the gas phase, I think. If we had a nitrogen tank, or you've got liquid propane for your barbecue, that it vaporizes so you can burn it. There's 2 phases there, the liquid propane and the gas phase. Well, there's no gas phase here, and we're not going to talk about the plasma phase. We're going to talk about the molecular structure when it's really tight. It's solid. In between here, you have a liquid, and if we were to add energy to this liquid, we could change the phase from liquid to a vapor. And this is the vapor phase. I forgot to say that. So the 3 phases of water are a liquid, a solid, and a vapor. And it's just the atomic spacing of the molecules.